Algebra lesson 11-2, operations with radical expressions. Like radicands are radical expressions that have the same number and variables underneath the radical sign. For example, I can have 3 square roots of 2x and 7 square roots of 2x, and those are like radicals. They're like radicands because the number and variable underneath the radical is the same for both of them. Unlike radicands are expressions that do not have the same number of variables. For example, I might have 2x squared square roots of 5y and 2x squared square roots of 5y to the 4th. Those are not like radicands. Those are unlike radicands because they don't have the same number and variable underneath the radical sign. A conjugate, unlike conjugates in Spanish class or English class, is the sum and the difference of the same two terms. For example, square root of 5 plus the square root of 2 is a conjugate to the square root of 5 minus the square root of 2. The first term stays the same, the last term stays the same, the sign between them changes. So if I had negative square root of 5 plus the square root of 2, the conjugate would be negative square root of 5 minus the square root of 2. The only sign that changes is the sign in the middle. To simplify sums and differences of radicals, you must have like radicands, much like having like terms with polynomials. So if I want to combine radicals, if they have the same number underneath the radical, for example, this is the square root of 2, this is the square root of 2, I can combine these now. Remember, if there's no number in front of a radical, there's the implied number 1. So I basically have 1 plus 4 square roots of 2. So we add these together, you get 5 square roots of 2, because 1 square root of 2 plus 4 square roots of 2 equals 5 square roots of 2. It's like saying 1x plus 4x becomes 5x. You don't do anything with the radical. It kind of gets tagged along like a variable. Right? If you don't have all like terms, you need to simplify with those that do have like terms. For example, 3 square roots of 6 and negative 4 square roots of 6 is one set of like terms, and 5 square roots of 3 and negative 9 square roots of 3 is a second set of like terms. So 3 square roots of 6 minus 4 square roots of 6 here, this becomes the negative square root of 6, or negative 1 square root of 6. It doesn't matter which way you put it. And then we have 5 square roots of 3 and negative 9 square roots of 3, so 5 minus 9 is negative 4 square roots of 3. So when we combine this, this becomes negative square root of 6 minus 4 square roots of 3, and that's my final answer. I can't combine the square root of 6 with 4 square roots of 3 because they're not the same square root. Now, if I don't have like radicals, you'll need to simplify a radical expression to see if maybe once you simplify it, you will have like radicals. So this is what we need to look at a lot of times when we are looking at our radicals. So if I have 8 square roots of 5 minus the square root of 45, I have no idea if I can add or subtract these until I simplify the square root of 45. The square root of 45 is 9 times 5, and 9 is 3 times 3. So now this becomes 8 square roots of 5 minus 3 square roots of 5, because we simplified this. 8 minus 3 is 5, so this becomes 5 square roots of 5. We could simplify this, which then enabled us to be able to subtract them. The square root of 20 minus 4 square roots of 5. Okay, let's look and see if the square root of 20 will break down. I know it will. This is 2 times 10, which is 2 times 5. So we have 2 square roots of 5 minus 4 square roots of 5, which becomes negative 2 square roots of 5. Because remember, the square root of 5 acts just like a variable would. It's kind of like saying 2x minus 4x would become negative 2x. Here it becomes 2 square roots of 5 minus 4 square roots of 5 becomes negative 2 square roots of 5. 6 square roots of 7 minus 2 square roots of 28. Okay, let's break down 28. 2 times 14, 2 times 7. So these two 2's get combined, they get put together with that 2. So we have 6 square roots of 7 minus 4 square roots of 7. And that becomes 2 square roots of 7. Square root of 125 minus 3 square root of 5. Well, square root of 125 is 5 times 25. 25 is 5 times 5. So I now have 5 square roots of 5 minus 3 square roots of 5, which becomes 2 square roots of 5. So adding and subtracting, they have to have like terms, just like polynomials had to have like terms. Now, when we simplify a radical expression that involves multiplication, we're going to use the distributive property. For example, if I have the square root of 5 and I'm going to multiply that by 2 plus the square root of 10, I'm going to distribute the square root of 5 to the 2, and I'm going to distribute the square root of 5 to the square root of 10. Remember, outside times outside, inside times inside. So the square root of 5 times 2 becomes 2 square roots of 5, and the square root of 5 times the square root of 10 becomes the square root of 50. Because both of those are underneath the radical, they need to stay underneath the radical, and they get multiplied together. Now, I need to see if the square root of 50 will simplify, because you have to make sure that you simplify everything once you have multiplied it. Okay, because it says simplify. So we need to get it all the way down. This is 5 times 10, which is 5 times 2. So this is 5 square roots of 2. So I have 2 square roots of 5 plus 5 square roots of 2. I can't combine those. That's as good as they get, but they are simplified all the way. So I have to take it all the way down to this. I can't leave it as 2 square roots of 5 plus a square root of 50. I have to leave it as 2 square roots of 5 plus 5 square roots of 2. Let's look at number 2. Square root of 2x times the square root of 6x is going to become the square root of 12x squared minus square root of 2x times 11 is 11 square roots of 2x. And let's see about simplifying 12x squared. 12 is 4 times 3. Oops. 4 times 3, and 4 is 2 times 2. So I have 2 square roots of 3, but I have 2x, because I can take out one of my x's. Square roots of 3. Oops, square roots of 3. Write this properly. Square roots of 3 minus 11 square roots of 2x. I cannot combine anything else, so I just have to leave it as 2x square roots of 3 minus 11 square roots of 2x. Interesting looking numbers when you're done. Number 3. Again, distribute. So I'm going to have the square root of 40 plus 9 square roots of 5. Whole number is always going to the outside first. 40 is 8 times 5. 8 is 2 times 4, and 4 is 2 times 2. So this is 2 square roots of 10. So 2 square roots of 10 plus 9 square roots of 5. I can't combine those because they're not like terms. So we leave it as 2 square roots of 10 plus 9 square roots of 5. Okay. When both expressions, if both radical expressions have 2 terms, you can FOIL or use the distributive property. Remember, FOIL is just a fancy way of saying you're going to distribute first, outer, inner, last. Okay. The same way you do with polynomials. Remember, if I had x minus 3y times x plus 3y, we're just going to distribute. Okay. So I'm going to distribute here. I'm going to take my first term, the square root of 6. I'm going to multiply it by everything in my second parenthesis, square root of 6 plus the square root of 21. Then I'm going to take my sign and the second term, negative 3 square root of 21, and I'll multiply that by everything in the second parenthesis, the square root of 6 plus the square root of 21. Okay, so if I distribute this, okay, I'm running out of space. I should have left myself some space here. Okay, if I distribute this first one here, I'm going to get square root of 6 times the square root of 6 is the square root of 36, which is 6, plus 6 square roots of 21. Down here in the bottom, when I distribute, I'm going to get negative 3 square roots of 21 times 6. Right, 21 times 6 is 12, so it's going to be 126. And then negative 3, right, and then we're going to get negative 3 times the square root of 21 times the square root of 21. The square root of 21 times the square root of 21 is 21. 21 times 3 is negative 63. So now I have to combine all of these. 6 plus 6 squared roots of 21 minus 3 squared roots of 126 minus 63. Okay, to do that, I'm going to have to look and see if the square root of 126 breaks down. 21 is 7 times 3, so I know it doesn't break down. The 126 is divisible by 2. It's 2 times 63. And 63 is 6 times 9. Or, again, 63 is not 6 times 9. 9 times 7. 9 times 7. 9 is 3 times 3. So this would be 3 square roots of 21. So this 3 gets multiplied by that 3. So we're going to get negative 6 square roots of 21. And so in this particular problem, I have 6 plus 6 square roots of 21 minus 6 square roots of 21 minus 63. Okay, so you'll notice my middle terms cancel out. Boom, boom. So I have 6 minus 63. Okay, 63 minus 6 is negative 57. So my final answer is actually a whole number here with no radicals whatsoever. Because it ends up to be what we call a FOIL. It's the difference of two squares. Okay, because I had, we'll look back at the beginning, this is an A minus B, and this is an A plus B. So my answer should have been, if you remember from chapter 9, A squared minus B squared. So it should have been the square root of 6 squared, okay? Square root of 6 squared minus 3 square roots of 21 squared. So this would have been 6 minus 3 squared is 9 times 21. 9 times 21 is, right? Oh, no, it's not, because it's not an A squared, so I have that right there. Never mind, that was wrong. Erase that. Make a mistake. Ignore everything. The final answer is the final answer. We're good. But we still end up with negative 57. Let's take a look at number 5. Okay. Again, we're going to have to FOIL. And there's a lot of places you can make silly mistakes when you're FOILing, so be really, 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 really careful. Okay, you don't want to mess these up too badly. Okay, so 2 square roots of 6 times the square root of 6. So 2 square roots of 6, I have my pen on, 2 square roots of 6 times the square root of 6 minus 5 square roots of 3. Okay. Plus 3 square roots of 3 times the square root of 6 minus 5 square roots of 3. Okay. I'm going to move this problem to later on in the page, so I'm just going to cross it off for now because I need the space because I like to work to the right. So this becomes square root of 6 times the square root of 6 is 6. 6 times 2 is 12. That becomes 12 minus 2 times 5 is 10, square roots of 18. Here, when I distribute here, I'm going to get 3 square roots of 18. And when I distribute this here, I'm going to get 3 times 5 is 15. The square root of 3 times the square root of 3 is 3. And 15 times 3 is 45. And it would be a positive. So now, if I look at these, I have 12 plus 45, which is 57, plus, oops, it's going to be minus because I have more negative numbers than positive numbers. Negative 10 plus 3 is negative 7, the square root of 18. Now I need to simplify the square root of 18. Okay, square root of 18 is 9 times 2, which is 3 times 3, so that 3 is multiplied by that 7. So I have 57 minus 21 square roots of 2 as my final answer. Or negative 21 square roots of 2 plus 57. It doesn't really matter. Okay. Let's look at number 6. So we put 6 in here. Remember, 6 was the square root of 7 plus the square root of 4 quantity squared, right? Yep, the square root of 7 plus the square root of 4, the square root of 7 plus the square root plus 4. And I can't remember what the original problem was. That's bad. Plus 4. quantity squared. We can either distribute it out, or you can remember your special products. This is an A plus B quantity squared, which is A squared plus 2AB plus B squared. My A term is 37, and my B term is 4. So my A term says A squared, so it's 37 squared plus 2 times the square root of 7 times 4 plus my B term, which is 4 squared. Don't get into the habit of doing this. I get people who look at these problems and go, oh, I'm just going to take that and go square it there, and I'm going to get square root of 7 squared is 7, 4 squared is 16, so it's 16 plus 7, and I'm done. You have a middle term here, because it's the square root of 7 plus 4 times the square root of 7 plus 4. So either FOIL it out or use your special products, but make sure you don't lose your middle term. Okay? So the square root of 7 squared is 7, plus 2 times 4 is 8, 8 square roots of 7, plus 16. Now I can combine my 7 and 16. 16 plus 7 is 23, so I get 23 plus 8 square roots of 7. And I'm done at this point in time. All right. The product of two conjugates results in a difference of two squares, and this product will never have a radical. That's what I love about conjugates. If I have the square root of 7 plus the square root of 3 times the square root of 7 minus the square root of 3, notice this is an A plus B, this is an A minus B. This is what I was trying to do a couple problems before that I messed up on because I didn't pay attention to the 3 in the middle. So this is just going to become A squared minus B squared. So if I know my A term is the square root of 7. My B term is the square root of 3. Right, so I'm going to get the square root of 7 squared minus the square root of 3 squared. Square root of 7 squared is 7. Square root of 3 squared is 3. 7 minus 3 is 4. I can FOIL it out. I can distribute it out, do it the long way. But you'll find that your middle terms will cancel out. So as soon as you learn how to do these using the special products, it will be much easier and much faster for you to solve these problems. Let's take a look at this one. Again, an A squared plus B squared, and A squared, or A plus B times A minus B, which is A squared minus B squared. My A term is 2 square roots of 3. My B term is 4 square roots of 6. Remember, signs are taken care of with the problem. So it's A squared, 2 square roots of 3, quantity squared, minus B, 4 square roots of 6, quantity squared. Distribute this square because there's no plus or minus signs. You can do that. 2 squared is 4. The square root of 3 squared is 3, so 4 times 3 is 12. Distribute here. 4 squared is 16. The square root of 6 squared is 6. 16 times 6, I believe is 96. Yes, it is. So I get 12 minus 96, which will give me negative 84. So when you multiply conjugates, you should not get any radicals. Okay, last little concept here. Remember, when simplifying a radical expression, you can have no radicals in the denominator. When a denominator contains a sum or a difference, including radical expressions, you have to rationalize the denominator by multiplying by the conjugate. I can't just say I'm going to multiply by the square root of 5 or I'm going to multiply by the square root of 2. I have to multiply by a conjugate. So in this particular problem, the conjugate of the square root of 5 minus the square root of 2 is the square root of 5 plus the square root of 2. And this is just another fancy word for the number 1, isn't it? Because the square root of 5 plus the square root of 2 divided by the square root of 5 plus the square root of 2 is just 1. So if I multiply the top, remember to distribute this 6 throughout this entire conjugate up here. I'm going to get 6 square roots of 5 plus 6 square roots of 2. On the bottom, I'm going to get the a squared minus b squared. So I'm going to get the square root of 5 squared minus the square root of 2 squared. So I'm going to get 5 minus 2, which is 3. Now, if you look at this, be very, very careful with this. I can look at this and say, wait a second. Since all of the numbers on the outside of my radicals, oops, right there, are all divisible by 3, and if I looked at 6 square roots of 5 plus 6 square roots of 2, I could factor a 3 out of that. This is the same thing as saying 3 parentheses 2 square roots of 5 plus 2 square roots of 2 all over 3. So this 3 will cancel with this 3, and I'm left with 2 square roots of 5 plus 2 square roots of 2. Simply done. All right, let's take a look at a couple more. We're going to simplify 4 over the square root of 7 plus the square root of 5. The conjugate of the square root of 7 plus the square root of 5 is the square root of 7 minus the square root of 5. Okay, so if we distribute it across the top, we get 4 square roots of 7 minus 4 square roots of 5. If we take a squared minus b squared, we're going to get the square root of 7 squared. So we're going to basically get 7 minus 5. Because the square root of 7 squared is 7, and the square root of 5 squared is 5. So that becomes 4 square roots of 7 minus 4 square roots of 5 all over 2. And this 2 goes into this 4 and this 4 twice. So we get 2 square roots of 7 plus 2 square roots of 5 as our final answer. Oops, minus 2 squared roots of 5. How did I do that? Be careful. You do silly things. Minus. There's minus up here. It needs to be minus down there. Okay, number 2. Conjugate of the square root of 11 minus the square root of 3 is the square root of 11 plus the square root of 3. Square root of 11 plus the square root of 3 over the square root of 11 plus the square root of 3. So on the top, we're going to get negative 5 square roots of 11 minus 5 square roots of 3. On the bottom, we're going to get 11 minus 3. So we're going to get negative 5 square roots of 11 minus 5 square roots of 3 all over 11 minus 3 is 8. Nothing simplifies because I can't take anything out of the 5 and the 8. So it just ends at this particular bottom right there. This last one's a bit more complicated. Not super complicated, but it can get a little complicated because the top is a little bit more difficult because we have a the polynomial versus a monomial here. So the conjugate is still going to be the square root of 9 plus the square root of 6 over the square root of 9 plus the square root of 6. The denominator is easy. It's the numerator that can trip you up. Because my denominator is going to be 9 minus 6. But my numerator is now a polynomial. A binomial times a binomial, so I have to distribute. And I'm going to do that off to the right-hand side here. So I'm going to have 2 square roots of 12, and that has to be multiplied by the square root of 9 plus the square root of 6. And then I've got plus 3 square roots of 6, I have to multiply that by the square root of 9 plus the square root of 6. So we're going to have 2 square roots of 9 times 12. It's 108, I think. Yep, 108. Plus 2 square roots of 72. Plus 3 square roots, 9 times 54. Plus 3 square roots of 36. I'm going to simplify that in a second. So 108 has to simplify. We have to simplify before we can figure out if we have any terms that we can combine. So 108 divided by 2 is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. So we take out a 3, we take out a 2. 3 times 2 is 6, 6 times 2 is 12. So that's 12 square roots of 3. 72. And divide out by 9, so it's 9 times 8. 9 is 3 times 3. 8 is 2 times 4, which is 2 times 2. So it's 2 times 3, which is 6 times 2 is 12. 12 square roots of 2. 54 is 6 times 9, which is 2 times 3, and 3 times 3, so it's 3 times that 3 is 9 squared root of 6. And up here, 36 is 6 times 6, and 6 times 3 is 18. Goodness gracious. So I look at this and go, gee, all of that, and I cannot simplify anything. So basically what this becomes then is 12 square roots of 3 plus 12 square roots of 2 plus 9 square roots of 6 plus 18, all over 9 minus 6, which simplifies to 12 square roots of 3 plus 12 square roots of 2 plus 9 square roots of 6 plus 18, all over 9 minus 6 is 3. But guess what? 3 can go into all of these numbers. 18 multiplied by 3, 9 multiplied by 3, 12 multiplied by 3, 12 multiplied by 3. So the 3 goes into the 12s 4 times. It goes into that 12 4 times. It goes into 9 3 times. It goes into 18 6 times. So my final answer, 4 square roots of 3 plus 4 square roots of 2 plus 3 square roots of 6 plus 6. My goodness, that's a long answer, isn't it? The more you do these, the better you'll get at them. So just have patience, and you'll understand that they will come to you, and I'll help you work on them in class. So this is operations with radicals.